I think we'll get started then. Hello everyone, good morning. Hopefully you're in the right room. A lot of you have been sat here for a few minutes, so if you're not expecting this talk, then I don't know what you were doing. So hopefully you are in the right place. This is my talk on how to stop the Gradle Snatchers. I talk about security, I talk about mobile security, and kind of how we can use some security tools within Gradle to improve our build processes. To kick things off, who am I? My name's Ed. I'm from Nottingham in the UK. I'm a lead Android dev at a company called ASOS. ASOS is a fashion company. It might not look like it, but I do actually work in fashion. So we sell clothes all over the world. I'm also an Android GDE in the Android profession. So I talk all over the place in many different conferences around the world, mostly about mobile security. I love talking about mobile security, but I'm not an expert. I'm just an enthusiast who wants to kind of pass on the knowledge I've learned over the years. I'm available on social media. I'm available on all good social media and Twitter. So please do check my handle. It's down the bottom here. You can also go to my website at the bottom, spaghetti.dev, for more information. And this is actually my first time in Lisbon. I've never been here before. Been to Portugal before, but Lisbon's wicked. I'm coming back. So hopefully I'll see you next year. Let's kick things off then. Supply chain attacks. What is a supply chain? What is a supply chain attack? Well, a supply chain attack is an attack on your tooling which aims to introduce vulnerabilities or malicious code without being detected by you, the developers. So this is kind of a part of your kind of maybe build process, or it's not they're attacking your application directly, but the processes that are involved in building it. So this talk is basically going to be a talk about how we can kind of avoid those situations and ensure that supply chain attacks don't happen to you, with the particular focus on Gradle. So without further ado, some of the things we're going to look at today, we're going to look at a couple of real world stories of where supply chain attacks have affected people and Gradle specifically. We're then going to look how we can secure our dependencies. I'm sure we all have dependencies. So Gradle has a few tricks and tips on how to improve that process. And then we'll talk about securing the tool itself, Gradle. How do we make Gradle secure in our apps? So without further ado, let's now talk about the elephant in the room. Gradle. Can I have a show of hands who uses Gradle at the moment? Everyone. I think that was everyone. Fantastic. So Gradle and Android have had a history for quite a long time. Let's quickly revisit the timeline of history we have with Gradle. There was a time before Gradle. I'm sure many of us remember these years fondly, when kind of Android came about in the sort of late 2000s. We didn't have Gradle. We had Ant. We had the Android developer tools. And it was I'm sure we all have very fond memories of those times. Again, hands up if you've been doing Android since then. Yeah, I can tell because you're the ones with the grey hair and the bags under your eyes. Yeah, I know, I was there too. However, if you weren't there, it was basically colloquially known as the Dark Ages. We had Eclipse, we didn't have Android Studio, we didn't have Gradle. It was a painful time, but it was a good time. It was important. We learned a lot from that. The good thing was, in fall of 2012, we started to see that Android was moving in a new direction. We got the very first V1 or V01 of the new build tool. At the time, it was called the new build tool. What that eventually evolved into was Gradle. So if we fast forward all the way to version 1, it took them a couple of years, but we got to the initial release of Gradle 1.0 or AGP 1.0 in 2014. So that feels like a very long time ago, and that's because it is, because now, present day, 3 days ago, I think AGP 8.6, I think, was released. So we've come a long way, basically, is what my point is. We've come a long way. Gradle has been with us now for over 10 years, and we're fairly comfortable, mostly, in using it. But I want to talk about I want to, go through a couple of examples of stories that have happened kind of along this timeline. And one of the really, I think, key ones that I like to talk about happened in 2018. Some of you may know this story, but the story is called A Confusing Dependency. So this story involves Martin. Now, some of you may know Martin. You may recognize his face. You may know him in person. He's usually at conferences. He actually usually walks in around now when I'm presenting his face, but he's not here, I'm told. Martin now works for JetBrains. He was previously DevRel at Google. But this story, back in the day in 2018, in his own words, was when he was a relatively inexperienced developer. He worked at a company, I believe, in Hungary and was working on a side project where he was creating an offline tool. This tool, it doesn't really matter for the purpose of the story what it did, but the important thing to note is it was offline. So, like any good developer, we occasionally need to get tools and third-party code from elsewhere. He found something that met his particular use case. Again, the library doesn't really matter in this story, but he fetched a dependency from Jetpack. I'm sure we all fetch dependencies every day in our project, and this should be no difference. So Martin had a specific need and went and fetched a dependency. However, when he ran his code after this dependency, something strange happened. Now, normally, I get this when I've forgotten to do something at the start of the app, but Martin was quite surprised. This dependency should have been an offline dependency. There should be no need for an internet permission. So what was going on? Very strange. What Martin did was take a look at his Gradle configuration. And again, this may look very similar to a configuration you have in your own app. And he decided to figure out where this dependency was being resolved from, because it couldn't be being resolved from the Jetpack because he knew what that dependency was. He could see it was open source. He could see what that code was doing. So the way that the repository block works in Gradle is it sequentially looks for dependencies line by line. So it would first start off looking for this dependency in the Google repository. Does the dependency exist there? No, it doesn't. Of course it doesn't. He then went to JCenter. We all remember JCenter, right? It's not around anymore, but at the time it was. Well, it shouldn't exist. So let me introduce the new actor into this story. Fake Wharton. You may look like somebody you already know. What has happened in Martin's case was a malicious actor had pretended to be Jake Wharton on JCenter and actually uploaded a version of the dependency Martin was using under one of Jake's well-known libraries. So what this user had essentially done was created a new repository full of libraries which were very common to use, but had shadowed them with malicious code within them. So this was the problem. What had happened was this Jake Wharton, this fake Jake Wharton, note the 2 A's, had supplied this dependency from JCenter, and yeah, it contained malicious code. And Martin had no way of knowing this. So I think the long story short here is what you really need to know is, first of all, we're glad JCenter's gone, right? JCenter was a mess. That was a Wild West. So that's gone. But you should also trust nobody. So there is a very, very good write-up of this story that I would highly recommend you read. Martin has got it on his own site, but I linked to that in my own site, so please do check that out. So this was a very frustrating and potentially in a live application, not a pet project, a really devastating thing to happen. Importing a dependency and getting code you don't expect and having malicious users being able to upload their own stuff and not being able to check that is, really scary and something that should hopefully be making you sweat a bit. So let's quickly talk about dependency verification. We'll talk about how do we verify that the dependency is what it says it is. So we can do that 2 ways. We can, first of all, check, is the integrity of my dependency compromised? I.e., are the files that the dependency pulls down the ones I expect? And then we can also check, is the origin compromised? So was it published by the expected author? And that's also known as the provenance. So if I say provenance, we're talking about the origin. We're talking about, is it coming from a legitimate place? Well, the good news is, and the reason we're here is because Gradle offers a solution for both of these points. The first point being checksum verification, and the second being signature verification. So checksum for integrity, signature for provenance. We'll go through both of these right now, and we can discuss how that works. So checksum verification. A checksum is essentially a hash on a file, and a hash on a file, you can compare against a known hash to determine whether or not a file has been changed. If you modify a file, even if it's a single byte, the hash will be completely different. So the idea is you hash files, and you're then able to kind of determine whether or not a file has been compromised. There are some common algorithms to use. You don't really need to know about all of them, other than there are kind of 3 common ones, MD5, SHA-1, and SHA-256. MD5 and SHA-1 aren't really fit for purpose anymore. I mean, MD5 I don't think has been fit for purpose for quite a while, and SHA-1 has also been proven to be broken in 2017. And this is because you can have what is called hash collisions. You can create a malicious file in a way where the two hashes can be the same. So SHA-256, for now, is the best solution when it comes to checksum verification. In the future, with quantum computing and all sorts, I mean, yeah, that's a whole nother conversation and for another talk at another time. So let's quickly just have a quick look just to prove my point. If we, in the command line, create a new hello world file, we can use SHA-sum, which is a common command line tool, to kind of output the SHA. The first example there is SHA-1, we don't really want that, and SHA-256, which we probably do. So if we had a file containing hello world and we wanted to compare it against another file to see if it's the same file, we could check that SHA at the bottom. So how do we set this up in Gradle? The task, yeah, so essentially what we want to do here is run this Gradle task. This Gradle task writes metadata for all dependencies in your app. If you run this task, if you note at the end, there is an optional task. I'll talk about that in a second. But if you run this without the task at the end, what this will do is take your default configuration and generate the SHA-256 of all the dependencies. You can add a task at the end. The task parameter is optional, but if you have different configurations, maybe you have a debug version of your app, maybe you have a release version, or maybe that you fetch different dependencies on different configurations, you can add an optional task at the end, and this will run the dependency kind of SHA-256 on all of those dependencies. So what does that actually do? I mean, that's very nice. I've shown you a command you can run, but what does it do? The answer is it creates in your project root a new file in the Gradle folder. It's called verificationmetadata.xml. And what that file contains is XML, and unfortunately it's XML, and I don't like XML. We're all past XML as Android developers now, aren't we? But yeah, unfortunately it's XML. And at the very top, you can kind of see the configuration. The configuration here is just saying that we are verifying metadata. We'll talk a bit in a second about the signature verification, but for now, because we've run this command, we're verifying the metadata, and we're going to get a list of components. If we take a look at components, so in this example, my application had the legitimate version of Timber from Jake Wharton. You can see it for each artifact, it has not only the name of the artifact that has been pulled down, in this case the Android AAR file, but also the SHA value for each one of those. So how this actually works in the background is quite simple. If you've ever kind of seen a raw Maven repo, they look like this. You have a whole bunch of files, you have a whole bunch of dependencies that you can pull down. So if you look towards the bottom of the screen, hopefully it's big enough for the people at the back, but there's a whole bunch of AAR files, and each AAR file has a known SHA-256 and SHA-512 even, like a file that goes along with it. So what happens is Gradle will pull the repository, get the dependency, and then add those values from the Maven repo into the Gradle XML file. So now, when you've run this step, if anything ever changes, if you ever were to then pull again your files and the dependency and something has changed, for example, maybe in this case, there's a discrepancy between the SHA and the actual file that's been pulled, you would get a compile error. You would get an error that's telling you dependency verification has failed. So this is a really important bit of tooling that can be used to stop dead any code being kind of pulled into your application that would otherwise kind of make its way in. So you can use, when you run this dependency verification, be able to get this to this step, very, very quickly, which is great. However, to kind of get this output, you do also need a Gradle property. Otherwise, your build will fail and not a lot of output will be there. So you do also need this property as well to be able to make sure that you can kind of get this verbose output to see what has gone wrong. Again, there is also kind of different ways of reporting this. So there are other kind of, I think, flags you can provide. So you can also get this as a HTML output if that is what you're after. So to kind of confirm, we would first run a list. When we've kind of got to a point where we're happy with our dependencies, we know what they are, we can manually kind of run the Gradle command. It will pull all of the SHAs, and then going forwards, we should be safe in the knowledge that those dependencies are safe. We'll talk more about that in a second. So the next thing I kind of mentioned was signature verification. So when we upload dependencies, we are often uploading them to public Maven repos. The most common one, I guess, being Maven Central, and they often require signed artifacts. Now, the artifacts are signed using something called the Pretty Good Privacy Standard, PGP, and developers must create kind of a cryptographic key pair to be able to kind of sign their artifacts to essentially assure that they have been created by the person they've said they've been created by. These public keys, so the private keys are kept obviously on the user's side who's created the dependency, but the public keys are published to a public key server. I believe Maven Central has about 2 or 3 different kind of key servers that they support, but I think for the vast majority of them, it tends to be the MIT key server that's kind of used for this. So you use the PGP standard. It's actually quite confusing. PGP is the standard, but you use GPG to sign the keys. So I always get that the wrong way around. Hopefully I've got that the right way around this time. But yeah, essentially you sign the artifacts and upload them to a Maven repo. So when the dependency author has signed them, how do we then verify that the dependencies they've uploaded are the ones we've downloaded? Well, we use another step within the previous command that we've seen before. So in this case, write verification metadata SHA-256 before, which was the dependency verification, and the PGP, which is now the author. What this does is very similar to what we saw before. It turns on the specific flag in your config, and then you also get a list of trusted keys. These trusted keys are the essentially IDs and hashes of the keys that have been pulled down locally and then compared against the library author. So in this case, this ID and all of this references Jake Wharton. So again, a visual representation of kind of how this works to hopefully kind of shore things up a bit. In the Maven repo, again, what happens is that we pull the ASC file. The ASC file is a kind of PGP signature file that's kind of associated with verifying the identity. And that comes along with the artifact as well. So each artifact has this ASC file along with it. And then here's an example of how this would work in real time. So in this case, I'm getting the GPG verification on a particular file. It's failed because I don't have the key for Jake Wharton locally. So Jake has helpfully put it on his website, so I can pull his public key, and then I'm able to verify locally, manually, kind of that the file is from who it says it is. There we go. It takes a little bit of time, but that is essentially how you would manually do this. But this is what happens behind the scenes. Gradle is doing this automatically for you, so we're verifying that each file is from the right person. But if you wanted to verify this manually, this is exactly how you would do it. So yeah, hopefully that makes sense. So there are pros and cons, as with everything, to this process. The very first thing is that you get trust in your app's dependencies, which at the moment you might not be in a place where you do trust your dependencies. If you're pulling dependencies every day, how do you know that where they're coming from? How do you know they are what they say they are? At the moment, you probably don't. Gradle is also flexible in kind of the levels of verification you wish to use. So you have the obviously the dependency verification step and then the signature. So you've got the origin, and the kind of integrity as well. You can be more hardcore, or you can kind of depend on your own needs, which kind of steps you use, whether you use one or both. Supply chain attacks are also mitigated. So supply chain attacks, as we kind of talked about, is something that we don't really think as developers. We don't really think about kind of, if we see an attack surface, the attack surface for us usually feels like the app. No, this goes beyond this. This is looking at making sure that we actually secure our tooling as well. And obviously by doing this, you're going to sleep a lot easier at night, and so will I, because I know you guys will be doing the right thing. But there are cons. There are always cons. This is really not a frictionless process. This is something that is quite frustrating. And when you are starting this process, you must start from a point where you trust all the dependencies. So if you were to run the scripts and the things that we've just looked at, you would need to, at this stage, manually verify every single thing and make sure that you are happy that you are starting from a point where you have complete trust. If you don't, then there's no point doing this. Because if you are not trusting the dependencies that you're downloading already, there's no point verifying that you're downloading a bad dependency. So my point is if you're going to do this, which I recommend you should, take the time to do it. Another bad thing is obviously it's XML. Had to throw that in because I'm sick of seeing XML. And yeah, actually the simplest solution for most developers, if you don't want to introduce problems with dependencies, is to ship with no dependencies, which sounds crazy. But a lot of high secure environments, banks, healthcare industry, a lot of they try and minimize dependencies. So maybe shipping with no dependencies might be difficult, but maybe shipping with fewer dependencies might be a good idea. Yeah, there's another step we can do as well. So this one isn't really kind of well, I suppose it is a security tool in some sense. It's repository filtering. So some of you might have seen this before. Gradle has the ability to kind of filter which packages can be fetched from certain repos. So for example, making sure that only Google dependencies are coming from the Google Maven repository. And making sure maybe in Marton's case, a really good example would have been Marton adding it to a dependency filter to make sure it only pulls from Gitpack. There are rules that Gradle provides to kind of include and exclude dependencies. It's very, very straightforward, as we'll see. And it works for dependencies and plugins. However, if you are using Gradle 7.0, there is a bug, and you need to make sure that I think that you need to, well, sorry, if you're not using Gradle 7.0, you need to make sure you are, because there is a bug prior to that. So yeah, please make sure that if you are doing this step, you're using Gradle 7 and above. But yeah, maybe a visual example is a little bit better here. So in this case, we might want to fetch certain dependencies. You can, again, kind of filter it by group or by module, or exclude by module, or exclude by regular expression. There's quite a lot of modifiers here that you can use. And in this case, yeah, we would be fetching things from com.example, a specific module, com.example.foo library, for example. And yeah, you might want to exclude all libraries by me. I don't know, maybe you do. So that is how you would do that. And the benefit of this is making sure that you gain the trust that your dependencies are coming from the right source. The ordering issue that we saw before, making sure that, going line by line, checking Google first, checking Maven for JCenter first, that's eliminated, right? Because if you have a complete set of rules, you would make sure that you are, you're always fetching from the right place. So you can kind of do this as complex or as simply as you like. And the other benefit, which is also not really talked about as well, is that you also don't leak your dependencies. And what I mean by that is if you're calling, for example, to a Maven repo and trying to fetch dependencies that don't exist, you are still pinging that Maven repo with a request. And that request is telling that Maven repo, hey, I'm looking for this library, I'm looking for that library. And if you had a malicious, I don't know, if you were feeling really sneaky and you wanted to create a malicious Maven repo, hey, you could ping and find what people are trying to search for, and then maybe, create your own kind of vulnerability based on that. So yeah, repository filtering is another kind of addition that you might want to add to your, to your tools. So that was, again, a very, very quick overview of the confusing dependency. Now I want to talk about something that happened not too long ago, a couple of years ago, the wrapper exploit. This one was a fun one. Here's a question, you don't have to know the answer, but think in your head, where's a great place to see hacking in the wild? If I wanted to go see somebody really pushing the boundaries of hacking, where would I go? Well, I'll spoil it for you. The answer is, of course, Minecraft. A lot of people on Minecraft, for whatever reason, just want to hack each other. For a game that is very peaceful and very something I find quite relaxing, there are a lot of people intent on causing other users a lot of harm. So this story, and I promise this is relevant, concerns a Minecraft server. And back in 2022, MinecraftOnline.com was the biggest and oldest, well, maybe not biggest, but certainly oldest multiplayer server in the world. It had 290,000 unique players. I think the fun fact is it opened 1 hour after multiplayer functionality was added to Minecraft. So it's been around a while. All you really need to know about Minecraft and why this is tangentially related to what we're talking about is that Minecraft servers use plugins. And these plugins are JVM language projects, like Android. And Gradle is the build system used, like Android. So this does work. I do promise this is relevant. What essentially happened was, there was a banned player. A user was, I don't know what they were doing, something malicious. I think they were trying to hack somebody, or they were trying to sell something illegal. I don't know. It doesn't really matter. They were breaking rules. I think it was distribution of malware actually. So yeah, they were being pretty naughty. And over a period of time, what they did was they became a totally legit player. They reinvented themselves. They came back, oh, I'm somebody else now. I'm somebody, over a period of time, I'm someone, I don't know that guy. Who was the previous guy? And what they ended up doing is getting in and socially engineering themselves into a position where they became a totally legit dev team member. So, I mean, there's holding a grudge, and then there's this dude. He was really searching for vengeance. So he socially engineered himself into a dev team member, and helped on some of the plugins. And one day, just made this commit. Yeah, just this. Nothing wrong with that. Can't see anything wrong. If I was doing the code review, looks good to me. Perfect. Totally fine, right? However, what he'd actually done there is distribute a modified Gradle Wrapper jar file. Now, this is something that sits in all of our projects. How often do we think about this file? I guarantee you, never. You're thinking about it right now, but that's only because I've just mentioned it. But never, right? This exploit he had written was only written to be exploited on the CI. So he'd done it in a way where, he could execute code, arbitrary code, when the CI was run. So yeah, essentially the attackers what he did was he created this malicious jar file, uploaded it to CI, and then got to a point where he was then able to kind of execute commands directly to the server. So he was able to give himself really good items. I don't know if that's any good, but he was also able to access the Linux operating system that ran the server as well. So that's a lot more scary than getting some good items. And essentially what he did with this was just cause absolute chaos and havoc on this server. However, this was actually the first time that was publicly documented where we had seen an attack on this kind of surface, on the Gradle Wrapper jar file. And this is a really good example of something that you might need to think about going forwards, especially if you work in open source, especially if you work in a large company where many people have access to your code base. This is something that you might want to implement. So how the hell do we prevent this? Well, like I said, this was the first public supply chain attack on the wrapper. And there is a way of verifying the wrapper's integrity that can prevent this. You can also verify the Gradle binaries themselves. That's another good step. And for what it's worth, all of the hashes of the wrapper and distributions are always available on Gradle's website. So there are tools, and if you wanted to do this step manually, you totally could. However, we don't want to do it manually, do we? We want somebody to do it for us. And helpfully, I've done it for you, partially. I've created a wrapper verification script here. It is just simply a shell script. You can just get it off GitHub. And what this will do is it will check that your wrapper file and wrapper jar are the expected values for your version of Gradle. So in this case, I've done it on Gradle 7.6.1, which is quite out of date now, but this talk's been around a while, so I apologize. And yeah, this is something you can run yourself. However, there is something slightly better than this. I made this for myself and then realized, oh, they've done it already. They have done it already. So if you use GitHub, this is probably the better step, and obviously supplied by Gradle themselves, so I would highly recommend using this. It is simply a GitHub action that you can add to your pipeline today, and you can probably do it right now on your phone whilst I'm talking, although please don't, because that will be distracting. But you could definitely do it after the talk. And what this does is exactly the same as before. It just basically verifies that the Gradle Wrapper jar is the one that it expects. So nobody can then kind of, hack your Minecraft servers, I guess. So what are the pros of kind of verifying the wrapper? Well, it's way more straightforward than kind of not verifying it. It's, you definitely don't want to be leaving yourself vulnerable, especially when something can be as slipped into a regular commit without being noticed like that, potentially. You can definitely do this very quickly, so it's something you could probably do before I finish the talk. This is something that you can fit into most CI pipelines, so even if you're not using GitHub Actions, you can use my script or write your own, and it's something you can implement, again, in probably about 5-10 minutes. And yeah, GitHub gets it for free, so you might as well add it. There are cons, the main con being still fairly unlikely anybody's going to attempt to attack your Gradle wrapper jar file. Otherwise, I can't really think of any cons. I think it is an unlikely attack vector, but it's one that you need to be aware of. So for the sake of adding something for 2 minutes, it seems pretty worthwhile to me. The next thing we can do is verify the distribution. So You've probably seen this file many, many times. It is the Gradle Wrapper properties file. It contains the URL of the distribution of Gradle that you're using. And what happens is when you run Gradle for the first time, it pings this URL and pulls down the Gradle binaries for you. However, how do we know that the binaries that we've pulled down are the legit ones? How do we verify it? Well, I'm glad you asked, because there is something called the distribution SHA-256 sum. And this is a property that you can add to your Gradle Wrapper properties file that will check the binary when it's pulled down against this hash to make sure that they match. And essentially, again, if you're ever kind of updating your wrapper properties file, this is a value that you can pull down from the Gradle website and add to your file. However, don't do that, because you shouldn't be editing that file manually. You should be doing it via the wrapper command. So please make sure you are verifying the distribution correctly, and that is by running the wrapper command with your version of Gradle and adding the flag Gradle distribution SHA-256 sum with the long SHA-256 value that's relevant to your Gradle version there. The other thing you need to remember as well, and this is very confusing, and I wrote a blog post about this because it also confused me, is that you need to run this twice. It's a weird quirk of kind of running this wrapper, but make sure that you run this twice because the first time, I think, make sure that it pulls it correctly, and then the second time, I think it also does the verification. So make sure that you run it twice. And what happens, I guess, if you don't, is exactly what you'd expect to happen. You fail at the time when your binary is pulled down. It's very difficult to see, I apologize again, but essentially what that's doing there is checking against the expected checksum and the actual checksum and failing. So yeah, again, it will stop your build in its tracks to make sure that, yeah, you're not pulling anything down malicious. So again, 20-second, 10-second change that you can add and add an extra level of security, and there are really no trade-offs here. Like I say, the pros, guarantees integrity of your Gradle distribution. So 100% do this, simple to set up. We've just seen how to do it in 10 seconds. It's one command run twice, and verification is very quick. It adds practically no time to your build time. So again, very worthwhile doing. However, there are cons. Yes, remembering to update the wrapper via the wrapper command and then doing it twice. Again, can't really think of any other cons. So if there are any other cons and you know them, let me know. But otherwise, again, something you can set up very, very quickly. But how do we verify the Gradle W file? The Gradle W file is the script that's run, essentially the wrapper to run Gradle. It's very overlooked. It's a bit of a shame. There is no official process for verifying this. You can roll your own solution. It should be fairly straightforward. You basically need to just have a thorough PR process at the moment to kind of verify that your Gradle W file has not been modified. But you can do me a favor, and that is by starring this issue or giving it a thumbs up on the Gradle repository to try and get some official solution here. Now, I think the official reason that they don't want to do this is because some people modify their Gradle W scripts. I don't know if anybody does. I've never done it, but apparently some people do, and they are worried that adding kind of a verification step might cause some friction. I think if it was an opt-in kind of solution, then it would be better, but okay, whatever. So in summary, let's kind of recap what we've seen. The Gradle supply chain attacks are very, very rare. They do occur though, so it's not something that we can totally forget about. You should definitely consider using dependency verification. It's something, again, that I've hopefully proven is something you can set up very quickly, something that will be certainly of benefit to you in your application. You can definitely use repository filtering even, just to make sure that you are pulling from the right place. And then verify your wrappers. Wrapper verification, as we've seen, is a step, and you can add it to your your GitHub repo very, very quickly. And then you can also verify your distribution. We've kind of also seen the steps there. But I hear you. I know what you're thinking. I want to learn more, probably from somebody that knows a little bit more. And there is a really great talk by Cedric from Gradle. He did that in DevOps 2019. So it's a little bit dated, but the points are all still relevant. And actually, a lot of this talk has unfortunately pulled quite a lot of information that can be found already on the Gradle security documentation. For documentation, it's actually really well written, really interesting. Highly recommend you take a look. We're not at Android makers, obviously, because I did this talk at Android makers. There are no humans from Gradle here, unfortunately, I don't believe. But there are plenty of people online and people to reach out to, so apologies that I forgot to take that out. But again, if you were asleep, if this wasn't something that was, you didn't feel like this was a bit too fast or a bit too slow or not quite right, this talk is actually now also available as a blog. So you can read it at your own pace. I've got all of the examples there. You can find this on my website at spaghetti.dev. And yeah, I would highly recommend this as kind of a follow-up and something maybe you can send to your team and say, hey, I watched this really awkward English guy give a talk, and yeah, he's got a blog. Cool. I have got a real special treat for you today. One-time offer. It's the DroidCon Lisbon 2-for-1 offer. I am talking again today here in a couple of hours' time. So please do come along for that. What we'll be talking about in that talk is nothing to do with Gradle. It's actually to do with how to keep your API keys secret in your app. If that's something you're interested in, come along. You're going to be my guinea pigs because I've not given that talk before. So hopefully it goes better than this. We'll see. Again, all of my stuff is available online. Please do check out my website. I would really appreciate any kind of thoughts and feedback on it. So yeah, do let me know. I'm on, like I say, on all socials. And yeah, thank you very much for having me. I've really, really appreciated being invited here. And yeah, thanks for coming.